Hello. In this lesson, we're going to continue to talk about solving trig equations and with some, more complexities. And last time, the last example we did was these tangent square minus 4 equals to 0. And so this time we're going to continue on this, and this is going to be example number 6. And the question I pick is, of course, from your homework. Okay, solve for x. And this equation is 9 times sine square x minus 1 equals to 0. Okay. You probably could almost anticipate what's going to be. So let's go through the algebraic steps. So right here we have 9 sine x squared minus 1. So we're going to add a 1 on both sides, so that make it equals to 1. And sine square of x, if we divide both sides by 9, we're going to get 1 over 9. And then take square root. And we will get 1/3 on the right-hand side. And the next one will be the absolute value of sine x equals to 1/3. Okay. And of course, we get sine x equals to negative 1/3 or sine x equals to 1/3. These are not special angles, not special terminals, but how do we deal with it, right? How do we solve these two equations? Well, we still go by definition. Definition tell us, right? Definition, if we recall definition, shall we recall the definition? Okay, so recall definition of sine, right? And here we said there's a x comma y is a point. It's a point on the terminal side of the angle. Okay, so here of the angle other than the origin. And the r is equal to x squared plus y squared. Okay, here to avoid any confusion, because here we have an x here, so we should not confuse with it. We should not be confused with it. So for clarity, actually, we could change, right? We could change. So this, how about make x to be, let's use red, and this is use blue. Okay, because we've been using red and blue for these representations. So red and blue. Okay, red and blue, which is something we have always been using. Horizontal measurement and vertical measurement, right? Red and blue. So I'm just going to change it to this color, right? Well, actually, we only have 2 colors here, except on the graph. Typesetting red and blue, red squared plus blue squared, right? Horizontal measurement and vertical measurement. Now, sine is defined as what? Sine of an angle is defined as the blue divided by the r. Okay, so now with that definition in our mind, right? So for the 1/3, obviously you have a blue. The blue is 1, right? And the r is 3. And over here is going to be also blue over blue over R, right? And here 1/3, we're gonna write it as -1/3. R is always a positive. R is always a positive. So we have these. So we have situation in the first situation, the blue equals to -1, right? And of course, R equals to 3. R equals to 3. So you see, this is not going to be a unit circle, right? But it doesn't really matter. It doesn't really matter. It's not special. And in this case, right, the blue is going to be +1. The blue is a +1, and the R is also 3. R is also 3. R is also 3. So here you can see from the definition, we could already decide, right? 1/3, right? A -1/3. So there are these two cases. Now, so let's look at the first case. Maybe I can use a table. Okay, let me use a table. For we set up 2 columns, right? For this case, we're gonna put it here, right? And for this other case, we're gonna put it here. So these are the 2 cases, right? So blue is -1, and R is 3. Oops, what am I doing? R is 3. Okay, in both cases that R is 3, right? So this piece is done. So we just put them more organized and then make it easier to move around. Okay, so this blue equals to 1, and this is R equals to 3. R equals to 3. Okay, so we got it organized. And next, we're gonna solve each one individually. Okay, so for the first one, so in the first case, right? In this case, what we have here is that for blue equals to 1, R equals to 3, right? Sine equals to -1/3. And these terminals is going to be in the 3rd quadrant and the 4th quadrant, right? So let's just draw this rectangular system. Okay, rectangular system. We're going to set it up. Okay, R is 3, so you can think of a circle with a radius equals to 3, or you don't have to worry about it. -3, +3, and there you go. So we got the system set up. So sine equals to -1/3. And so now let's pick up the point, right? We got the blue, right? We got the blue equals to -1, R equals to 3. So blue equals to -1, where do we find those? It's gonna be underneath, right? Somewhere, but we don't know the X. If you want to find the X, it shouldn't be too hard, right? So let's give us some, in this question, it's not entirely necessary to find the red, but as a general knowledge, knowing how to find the red is actually very, very important for you, for your future studies. You can see that in this case, right? If you can draw these on your paper, the blue is a -1. We know the blue is it's a vertical measurement, right? So it's somewhere, I don't know where it is. I know R is 3, right? So you just draw the 1 and approximately 3. So there's 1 here. R is 3, so it's approximately 3, something like that. And so the blue, this is the blue, and there's a red. The red, of course, is to be found. right? If we really want to find the red, we just use Pythagorean theorem, okay? So the red, right, the red would equal to the square root, right, of 3 squared, which is 3 squared minus 1 squared, right? Okay, this is 1, and this is Pythagorean theorem. So this is 1. Okay, I try to use the color coordination. And the hypotenuse is 3, right? Hypotenuse is 3, blue over 3. I'm sorry, this is -1. This is -1, my bad. -1, right here, -1. Okay, -1 here. And there's another -1 on the other side, right? So don't forget that. So there's another -1. Okay, on this side. All these drawings are approximate, okay? To get a more precise drawing, you will have to find the red. You will have to find the red. Okay, so there's another red. There's another red. Of course, this piece is negative. So we just need to find one of the red, right? This red on the right side. It's much easier to do with that. And simplify, so we get square root of 8, right? Square root of 8. And if you simplify, that's going to be 2 times square root of 2. And there you go, you got the red. So this piece will be 2 times square root of 2, and the other piece is a negative square root of 2. So there are 2 terminals solutions for that equation, for that if statement, for that output, right? You can see what we done here. We did a DRA, right? Identify the terminal, DRA is about to be done. So right now we just, from the definition, we have just identified, okay? So from ARD, right, from definition, excuse me, we just identify the reference angle. We just identify the reference angle. So the reference angles, which are to help us to identify the terminal. And next, we're gonna measure the angle, right? How do we measure the angle, right? Counterclockwise, clockwise, terminates at these 2 terminals, and we got the angles, right? So now, for you to reflect on these, I'm going to just put these numbers in place. Okay, put these numbers in place. And meanwhile, if you like to draw, so we got the red, we get the blue, we can draw the point. We can draw the point. Okay, so the red is 2 times root 2, comma, -1. So that's 1 terminal, right? So that's 1 point on the terminal, right? And this will be the terminal. And there will be another one right there. 2 terminals identified, right? And the red, so let me draw the red. So this way, when we draw this, it just looks nicer. It just looks nicer. So the red, so let me make this the red, right? 1 red, and there will be another red. There will be another red. Oh, sorry, I need to make it red. Make it red. Okay, so 2 red, and there's 2 blues, 2 blues. Okay, so the two blues, this one will be 2 times root 2. No, sorry. 2 times root 2. 2 times root 2. And that will be the blue. In this process, I hope you understand what I'm trying to do here, right? It's just what we just drew red and blue. So to satisfy this if statement, right? If this statement is true, we possibly could have two terminals. We possibly could have two terminals. Okay, so we got them, right? So what are the angles? What are the angles, right? So we got from definition, we got the reference, we use the reference angle, we identify the terminal. Now it's time to identify the angle. Angle is what we're looking for, right? We're looking for angles. So the angles are, so what are those angles? They're not special, but we can express one of these angles, this angle. So here's the angle. This angle, we call it theta. How do we represent this angle? That's the question, right? How do we represent this angle? This angle is in the range of arc sine. So we can use arc sine to represent it, okay? So this theta can be represented as the following, okay? So we can use theta. We can assume theta equals to arc sine of negative 1/3. Negative 1/3. So that way we're going to represent the solutions. Okay, so we can represent the solutions now. The solutions are, there's one terminal here. So theta, so one solution, one set of solution will be theta plus 2k pi. Okay, and the other set of solution will be, how would you represent this other angle, right? This other angle. This other angle will be measured. You can measure clockwise, right? But what would this angle be, right? If we go further, we get negative pi, right? So negative pi is subtracting theta. Okay, so negative pi is subtracting theta. So we will be back to this angle. Okay, so the next one will be x equals to negative pi plus theta, and then plus 2k pi. Plus 2k pi, okay? Or you can measure counterclockwise. So to represent solutions for these two, and we got a solutions over here. Okay, these two solutions. How about for 1/3? For 1/3. 1/3 can be done in similar manner. Okay, 1/3 can be done in similar manner. So in summary, okay, we'll summarize afterwards, right? 1/3 for the second case, right? Everything's gonna flip up, right? The red is gonna stay where red is, but the other numbers, right? All those other things, right? So the negative will become positive. So this will be positive 1. Okay. And this will be positive 1. And this should do it. All flipped up. See? So these two terminals, right? Then you're going to introduce another theta. You're going to introduce another theta. But the interesting thing is that you cannot introduce two theta, which are different values, right? So you need to make some adjustment. So what are the adjustment? Okay. So suppose I'm not going to call theta. I'm going to call this one, I'm going to call this angle alpha. Okay, alpha. And what is alpha? Okay, alpha is arc sine of 1/3. Alpha and theta actually are opposite to each other. So if you introduce alpha, you will notice that alpha and theta actually are opposite. So alpha is actually negative theta. It's the opposite of theta. Theta is just measured clockwise, and alpha is measured counterclockwise for the same amount of opening, for the same amount of opening. So you decide which one you use as alpha, which one you use as theta, but they have this relationship. Okay, so the solution can go like this. The solution, of course, is one solution would be x equals to alpha, okay, plus 2k pi. And the next one will be x equals to this other terminal, right? So this is alpha, right? And this other one is pi minus alpha, right? So that's going to be pi minus alpha. So pi minus alpha plus 2k pi plus 2k pi. So get two other solutions. Okay. Now we have 4 solutions. We have 4 forms of solutions. Okay. So let's put them together for our summary. So over here, right? So we have 2 cases. I'm going to bring them down. So you can see for yourself. Okay, we're going to make some adjustment. Okay, so I'm going to add some rows. For sine x equals to negative 1/3, we have a picture right here, right? These are the terminals, and for equals to 1/3, and these are the terminals, right? We introduce theta, alpha equals to that, right? So alpha equals to that. And what is theta? We introduce the theta, theta equals to that. Okay. And we know alpha and theta are opposite to each other. And we also have the general solutions. So alpha equals to that, or the 2 forms of solution. Okay, pi minus alpha. Okay, for theta, we get 2 other solutions. Okay, so these 2. Okay, it doesn't paste because I know the reason. This software has some limitation. So I just have to copy one at a time. Okay, and next one. Excuse me. Okay, right here. These 2 can actually be written in the same form. These 2 can actually be written in the same form. Okay, so I'm going to show you something. That's here. We're still keeping the alpha. Okay, we're still keeping the alpha. For this other terminal, what I measured earlier is the clockwise measurement. We can use the counterclockwise measurement. If we use a counterclockwise measurement, so this angle is pi minus theta. Why minus theta? Because theta itself is negative. Okay, so here you can totally write it as pi minus theta. Okay, so then these 2 forms will be similar. Now the question is, you have an alpha and theta. Is it necessary? Is it necessary to have two? I would say it's not necessary. So we want to combine them. We want to combine them, right? So we're going to use, so this is going to be negative alpha. This is a negative alpha. Okay, so you can put a theta in the play, replace the theta by alpha, and replace this theta by alpha. And there you go. So this is now what? Pi plus alpha. Pi plus alpha. So now we get two solutions, right? These two will combine into, so let's look at our solutions, right? Let's look at our solutions. X will be equals to, combining these forms, okay? Combining these forms. So for these two, we basically have plus minus alpha plus 2k pi. Plus 2k pi, okay? And over here in the second form is pi plus or minus alpha, okay? So pi plus or minus alpha. So these two forms, we don't need that. And k, of course, are integers. So in the end, we can combine our solutions into this final form, which will cover all of the solutions. So this question seems to be rather complicated. Okay, if you have any questions, please don't hesitate to reach out to me, Okay, so we don't need to introduce theta, and you can just use alpha. You can just use alpha, or everything changed to theta. You will get a similar form. Okay. So that is the question number, is it 5? Number 6. Now let's look at the question number 7. Okay, number 7, example number 7. Okay, example number 7. For example number 7, of course, is solve for x. Right, so here you have sine square x minus sine x minus 2 equals to 0. Okay, we can do graph, right? But in most of the cases, this graph is not going to give you a clear indicator as to what the solutions are. And you can identify whether you have solution or not. So it would be much better off that we just start out with the algebraic approach. Okay, to solve this equation, first thing we're going to introduce u equals to sine x. Okay, so now this is going to be u squared minus u minus 2. Right? What is this equation? This is a quadratic equation, right? This is a quadratic equation. So we can solve it by factoring. And so that's going to be u plus 1 multiply u minus 2. Whoops, u minus 2. Okay? And we got two solutions for u. Okay, so u plus 1 equals to 0, or u minus 2 equals to 0. And next, of course, we get u equals to -1, or u equals to 2. U equals to 2. Okay, so let's do one at a time. Okay, when we do it one at a time, we're going to take sine x back to our picture. Okay, so sine x equals to -1. Okay, so you will say for u equals to -1, sine x equals to -1. Okay, And this is something we have done before, right? We've done something like this before. So sine x equals -1, you first identify the terminal. I think this was in the homework. Okay, this was in homework. We actually didn't do it in class, but that's okay. We can do it now. So sine x equals -1. So the blue number is -1. Where do we find the blue number that equals to -1? The blue number, let's find it, -1. There, we found -1. We found it right here. Okay, so that's the terminal. This terminal is a solution. All the angles that terminate on this terminal will be solutions. So what are they? 3 pi over 2, -pi, right? And then 5 pi over, you just, how do you do it? Plus 2k pi, right? Plus 2k pi. So once you identify this terminal, it's just a matter of plus 2k pi. Okay, you wish to represent it in the simplest form possible, which is -pi over 2, right? And then plus 2k pi. And that's it. You found your solutions. Okay, and k is integer. K is integer. Okay, but how about the other one for u equals to 2? For u equals to 2. What happened for u equals to 2? For u equals to 2. And that means sine x equals to 2. What are the solutions to this simple trig equation? At this point, you may like to pause the recording and think about it yourself. So now I assume you're coming back. Okay. Excuse me. So what is the solution? No solution. Why? Why? Because of what? Because sine x, the range of sine x, right, is between -1 to +1. For what? For any real number x. For any real number x. And of course, this is not going to happen. Sine x equals 2 is never going to happen. Not in a million years, right? So finally, in conclusion, what will be the solution? So finally, the solutions to what? The solutions to what? To that equation are what? Right here. We only have these solutions. That's all we have. However, this question can be done slightly differently. Okay, another way to do it. Another way that you don't introduce, you just don't introduce the intermediate variable directly. Okay, so what I meant here is that you're going to do it slightly differently. Okay, so I'm going a little faster here, right? Instead of you don't introduce that. You don't introduce that. Okay, so you just put sine x and sine x, and that's all gone. Okay, at this step, you recognize that sine x minus 2, this number is always going to be negative. Okay, this number will never be 0 because sine x. So you can say, since, okay, just another way to put it, sine x, right, is always between -1 and +1 for any real number x, right? And therefore sine x minus 2 is always negative for any real number x. Okay, as a result, if this is 0 and the next one sine x plus 1 has to be 0, it's because this will never be 0. This piece is always negative. Then from here, right, you can just go straight there. You can see the power of knowing the domain and range of these certain functions. It can really save you time and energy. Okay, it can really save you time and energy. And of course, you can put this down to tell the reader, right? You can even make some marks on this picture to tell the reader, hey, you know, this is terminal I found. Right, you can also, okay, you can also just draw a picture. You don't have to have this unit circle. Remember all of these things here, right? You don't need to. The simpler, the better. The simpler, the better. If I were you, right? If I were you, I would just do the following. Okay, I'm not using the unit circle. Okay, what I'm going to do, I'm just going to tell the reader, and this is the terminal. Okay, this is the terminal. It doesn't matter. You can draw unit circle, or you can draw your coordinates any way you want. Okay, you can draw your coordinates any way you want. The most important is to identify the terminal. Okay, so I'm identifying my terminal, and my terminal is right here. Okay, that's my terminal. Maybe I choose a different color. That's terminal. This terminal will give me, you know, sine x equals -1. Okay, you can pick any points on the terminal, right? It will always give you that. So this is the angle, and that's -pi/2. And then you can measure clockwise, counterclockwise. So the solution, the way you express solutions is not unique. Okay, so we can just remove that using this picture, which is simple and straightforward, right? An alternative solution, there are so many alternative solutions, alternative expressions. Okay, it's not alternative expressions. Okay, let me put it this way, right? Alternative expressions could be totally different. It could be like 3pi/2. Okay, it could be 3pi/2, right? That will work too, right? And if you plus 2pi, you can get a lot of many different alternatives. The options, the many alternative expressions for the solution, really, right? But which one do you choose? I would choose the simplest possible. And it turned out to be, I think this one is the simplest. Okay, the simplest. But anyway, so that's about this question. That's one of the question in number 7. I think this is example number 7. Okay, let's do another one. Let's do another one. You can see in these questions, what makes it complicated is that you have these quadratic function behind it. Okay, so let's look at example number 8. Okay, still solve for x. Okay, and we got 2 times cosine squared of x minus 3 times cosine x plus 1 equals to 0. Okay, does it look like a quadratic already? I think once you start to turn on that sense, there might be it might be quadratic. Quadratic is used a lot in academic questions, and you are in academics. You're taking these academic courses, so you will often encounter these quadratic forms, which we have here, right? So factoring will be the next in consideration. Okay, so to factor, you can introduce a variable explicitly or not. Okay, so for example, if I introduce it, then my equation will turn into a quadratic equation. With a quadratic equation, we know how to solve it, right? We know how to solve quadratic equations. We talk about there's three ways to solve quadratic equations. And factoring usually is our first choice. Why? Because factoring make it easier. Factoring make it easier. But in the case that you don't factor very quickly, then, well, just use quadratic formula or completing a square, whichever one that takes your fancy. Okay, so let's factor this. Factor this, and then I'm just to review the form that we use to factor, right? We have a couple columns, right? So I'm going to move this to the center a little bit, right? So 2 equals to 1 times 2, and 1 is equals to -1 times -1, right? And the cross multiplication, you should be pretty familiar with this form. If you don't, you have other forms that you are more familiar with, feel free to use them, okay? I'm not going to restrict you to have used my way or other people's way. So -2, 1 times -1 is -1, and the sum is, we're going to add these two numbers, right? We're going to add these two numbers. That's -3. That makes the perfect match. Okay, if you recall what we did, right? Cross multiplication. Okay, cross multiplication. So -1 times 2, -2. 1 times -1 is -1. -2 plus -1 is -3. -3 matches this -3 perfectly. So now we can compose our factors. Here we go. So here we go. Okay, we got to compose our factors. Let me insert one more column. There we go. Oops. That's the wrong place. Okay, so put a new column in the front. There we go. Okay, so this first row is u minus 1. U minus 1 is going to be that factor. And this one is 2u minus 1. So we got them. We got the factors. We got the factors, right? We got the factors. Take a close look and double check. Okay, so now we got the factors, right? If this is true, then I'll give you a shorter version of this, okay? Times 2u minus 1. 2u minus 1 equals to 0. And here we go. We got u minus 1 equals to 0. Or 2u minus 1 equals to 0. So we get two solutions for u. U equals to 1 is one solution, right? And the other one is u equals to half. And then you know what to do you? Of course, we're going to do it together. Just for u equals to 1, we got our cosine x equals to 1, right? So for u equals to 1, we get our cosine x equals to 1, okay? And of course, we have a for u equals to half. So u equals to half, we got a cosine x equals to half. All right. So now for u equals to 1, this seemed to be cosine x equals to 1, right? If cosine x equals to 1, you can look at the unit circle. Okay, and find the terminal where the red number equals to 1. Which red number equals to 1? Right here. Do we have another one? No, there's only one, right? So any angle that terminates on this terminal, and that's it, right? To keep it simple, I like to keep it simple. Okay, I like to keep it simple. So y equals to 0, I just have to mark that terminal. I just have to mark that terminal. Okay, so I'm going to show you how to mark it. In this case, right, the terminal you have to mark, it's really it's pretty straightforward. Right here, it doesn't matter how big, how wide you draw this. We know the terminal is the standard position, is in standard position. You just have to mark that line. Okay, so I'm going to mark it. I'm going to mark just that. Okay, we're going to use a color that will show. Okay, so that terminal. So what are the solutions? Right, that's only terminal. That's only terminal, right? So x will equals to 2k pi, 2k pi, right? K equals 0, 1, 2, 3. Multiples of 2 pi. K are integers. Right? So like whether you can use either one, really. You can use either one. Okay. And the second one, for u equals to half, this looks like a special angle, isn't it? Right? Cosine x equals to half. So you've been looking for a red number equals to half. So what are the red numbers equals to half? Let us find them. Oh, this red number equals to half, right? Do we have another one? Yes, we have another one. Do we have more? No. The quadrant 2 and quadrant 3, all the red numbers are negative. So we found it. We found two terminals. We found 2 terminals. This terminal and that terminal. And they're special angles. They're special angles. And the solution is at your fingertips, isn't it? Of 2 terminals, right? So the solution is going to be either pi over 3 plus 2k pi, right? Or negative pi over 3, right? So plus or minus pi over 3, 2k pi. And k are integers. Okay, so finally, the solutions are, right? Solutions to what? Solutions to this, where's my cosine? There. The solutions to this piece. What are the solutions to this piece? Are, right? There's 3 forms. One is this piece. or the next piece is right here. Okay. How much work to show, right? Show work. Show work. How much work shall we show? Okay. If you show work, you can certainly introduce all of these, but I'll put the factoring part not so visible. Okay, because the factoring is usually okay. So I'm going to just put the factoring part on my scratch paper. Okay, so I'm just going to remove that. You just do your factoring elsewhere. Okay, and then you get your solution, right? You get your solution here, right? So this is one solution, and for the other one, you have a solution, right? And you summarize. You have three forms. You have three forms. Do you have to factor x, by introducing this intermediate variable? No, you don't have to, right? If you don't, another way to show, if you don't show your, if you don't introduce the intermediate variable, which I sometimes tends to do, right? And then you just, you actually do some work behind the, I would say on the scratch paper, So this is your cosine, and this is 2 times cosine, right? Then you get two solutions. So your work, the work you show on the paper actually is much shorter. But doesn't mean you don't, it doesn't mean you just, you see it, you see through 5 steps. You do your rest of the work on the scratch paper, okay? And but you whoever your teacher is, and he or she probably will be just as happy to see your work like this, okay? And and then you can just use one unit, one picture, right? This is one picture, and you can show, you can show another picture using your unit circle to demonstrate that you know what you're doing. You know what you're doing. Okay, so you get your solution. You get your solution, right? So you have x equals to this. So this way you see your work is much shorter. Your work is much shorter. And the other piece you're gonna show is or right there. Right there. Right there. It can be just very short, and this is much shorter. Okay, let's see if I can fit in on one screen. I certainly can. You see, just this much work is perfect. It's great, right? Okay, and this is enough. This is enough. Are you going to lose points? No, I don't think you're going to lose points. Okay, I don't think you're going to lose points. You just move some of those work on the scratch paper. Okay, as you move forward with your, being in calculus class, in pre-calculus class, your professor doesn't need to see how you don't need to show your professor how to do factoring. Most of the professors, they assume you know it. Okay. And of course, if you show, make sure you show them correctly. If you don't show correctly, you risk the points. You're risking your points. Okay, so you better scratch them out on your scratch paper and scratch them well. And I think these examples, let's see, How many examples have we done? Yeah, there you have quite a few quadratic form, okay? So let's look at another form. Let's look at another form, okay? All of these actually are pretty easy to factor, right? So let's look at example number 9. Example number 9, of course, is solve for x. Okay, I pick another question from your homework. This is a cosine square of x plus sine x equals to 0. Well, this is not exactly quadratic form, but maybe we can change it to quadratic form, right? Because we know that a sine squared plus a cosine squared equals to 1. So sine squared of x plus cosine squared of x equals to 1. So I can replace cosine square x, right? Cosine square x by 1 minus sine square x. Okay, so you can see we're gonna do a substitution, and this piece will turn into cosine square x is replaced by sine square x. And that replacement will lead us to this quadratic equation. And this quadratic equation, if you put a 1 behind it, that's a quadratic equation. If you don't like to see this negative sign, multiply both sides by -1, okay? So then you're gonna get a sine squared of x minus sine x minus 1 equals to 0. Let's see, what do we get from here? It looks like it's gonna be hard to factor. It's going to be difficult to factor. And then what do we do? Right, factoring is difficult, but this is a quadratic equation, right? So let's see if we can do something to help us see better. So introduce u, so we got u squared minus u minus 1. It's a very simple looking quadratic equation, but it's very, very difficult to factor. You can try it, okay? It's very, very difficult to factor. You know what? At this point, I'm just going to jump in quadratic formula. Okay, quadratic formula. So a equals to 1, b equals to -1, c equals to -1. Okay, so I'm going to do my discriminant. Discriminant is b squared minus 4ac. Right, this will tell me how many solutions are to be expected. So -4 times a is 1, c is -1. Simplify. Looks like this is a 1, and this is going to give me a 4, and the whole thing is going to be 5. All right. Well, let's find the u. So u is equals to -b, so negative of -1 plus minus square root of discriminant. Discriminant is 5, right? The denominator is going to be 2 because a equals to 1. Let's simplify. Let's simplify. So we have +1 here. Plus minus √5 divided by 2. Ooh, so we get 2u, okay? So u sub 1 equals to, I'm going to make that equals to 1 minus √5 divided by 2. And u sub 2 is going to equal to 1 plus √5 divided by 2. Okay, So let us see, what number do we expect? This quantity, so we're gonna have two cases, okay? So for u equals to, so for u1 equals to that, our sine x is equals to that piece. Okay. And for u2, right? For u2, our sine x is going to equals to u2. Let's solve these two equations. They look intimidating, aren't they? There's not to be afraid of, okay? Don't be afraid. But one thing you need to check is that knowing the domain, knowing the range of sine, we want to make sure that these numbers are within the range of sine, okay? Why? If they're outside the range of sine, then there's no solution, okay? So how about this number? Well, if you like to estimate like I do, and I think this number is inside the range. This is a negative. This is a negative number, right? Because negative root 5 is larger. I mean, in absolute value is larger than 1. So the numerator is going to be negative. But the question is the numerator, after the numerator is going to be, you know, root 5, it should be equals to 2 point something. Right, 2 point something, negative 2 point something plus 1 divided by 2. So this number is going to be inside the interval of -1 to +1. That's all I need to know, okay? Which is the range of sine. This is important, okay? But if you like to just punch in the calculator, get a numerical value, there you go. So that confirms our estimation. But we're not going to use that approximation. Okay, those just, then you may think, oh, how about this piece? This piece, I think, is going to be larger. Why? This is going to be 2, more than 2, right? More than 2 plus 1. It's more than 3. More than 3 divided by 2 is going to be more than 1. So this numerically is outside the range, okay? So this is outside the range of sine x. Outside the range. Out of the range. Out of the range of sine. So this piece has no solution. This piece has no solution, right? You can see it's very useful to know the domain and range of these functions. So we only have one piece to deal with. We know this is a negative number. This is a negative number, right? So we're solving for x. And knowing this is a negative number, we know this is a negative. Right? And how many terminals are there? 2. One in quadrant 2, 3, the other one in quadrant 3. Okay, so this is going to be, I'm going to draw the rectangular system. It really has no difference in terms of doing it. Okay. The only thing is that the value looks a little yucky. I hope you're not grossed out about it. Okay, no problem. You handle it the same way. You handle it the same way. Oops, what did I do here? Oh, there. Right, I just want to have a nicer picture. Okay, so we get this rectangular system. We get a rectangular system, and what do we do about it? The definition tells us The definition tells us this is the blue over what? Over R. So R is 2, the blue is what? 1 minus root 5, if you want to, if that's what, you know, if you want to do it, right? Let's go. Let's do it, right? You would do this the same way. Okay, let me show you which example we did earlier. The same way we did it. Where is the sign? There. The same way we did it here. No difference. No difference. Okay, we just have two terminals. It's actually similar to this situation. Okay, similar to this situation. The only difference, what is the difference? The only difference is that the y is different and the r is different. Okay, so we're going to make adjustment accordingly. Okay, so I'm going to put this picture here and I'm going to make these pictures over here so you can see the similarity. You can see the similarity. Okay, so get used to this, right? It just tells you the blue is 1 minus root 5. And these blues are -1. That's the difference, right? So the blue is 1 minus root 5. And let me draw the picture. Now. Okay, so the blue and the R is 2, right? So we're going to have something like this. And the R is 2. The blue is this piece. Okay, and we have another piece on the other side. Okay, and this is the blue. Okay, and the blue is the same. Okay, the blue equals to 1 minus root 5. Both blues, both vertical blue. Okay, so let me not confuse you. Okay. Okay. So the blue will not be confused. We have two blues here, right? One blue, another blue. The two blues at the same value, 1 minus root 5. And the R is 2. Then you say, can we find the red? Of course we can find the red. And this is red. And that's the red. You see the picture already looks similar, right? So let's go about to find the red. Okay. Take this picture, take this side, right? Because this side is simpler, right? This side is simpler. So now the red should equals to the square root of the hypotenuse, which is 2 squared minus the blue squared, okay? And let's see, what is the blue squared? The blue squared is 1 minus root 5 squared. 1 minus root 5 squared. This is going to be so much fun, right? You probably have never been challenged by these kind of questions. Now you can see you're doing it, right? You're doing it with me. And make sure you do it after the class. Okay, after the class, try to do it. That's in your homework. Okay, so 2 squared minus the blue squared. The blue is 1 minus root 5, so 1 minus root 5 squared. Okay, so let's have the patience to finish it. What are we getting? So this is 4. And we're going to open up the parentheses. I'm going to put them in the bracket. Okay, so because there's a negative sign outside, right? So this is going to be 1 squared. 1 squared is 1 minus 2ab, right? 2ab, a minus b squared, right? So I'm going to put it This is a minus b squared equals to a squared minus 2ab plus b squared, right? A familiar formula, So now we'll take this formula on 1 minus root 5 squared, right? So 2ab, 2 times ab, that's 2 times root 5. Okay, and plus b squared, root 5 squared, root 5 squared, root 5 squared, right? Root 5 squared is 5. Okay, so 1 plus 5, that's a 6. Okay, I'm gonna write one more step. So this is gonna be 6. Right, so if we opened up the parentheses, so we're gonna have 4 minus 6 plus 2 times root 5. So this is gonna be plus. And 4 minus 6 is negative 2. Negative 2. So inside the parentheses, so if you put a minus 2 behind, and that's the red. That's the red. I know this number looks like so bizarre, but it is a number. It is a number. Get used to it, okay? Get used to it. So we got the red, we got the blue. The blue is 1 minus root 5, and the red is this piece. So let me draw the picture for you. Okay, I'm gonna draw the blue for you. I draw the blue and red for you. Okay, the red, right? So I'm gonna draw the red. The red. Okay, I'm gonna draw the 2 reds. There you go. Okay, so I'm gonna remove those. You see, we got the 2 reds, right? Let's look at the blue. I'm gonna draw the blue. Okay, the blue. We got the red. Right, next we're gonna draw the blue. So I'm gonna put it over here. And this is gonna be 1 minus root 5. And that's gonna be blue. There, 1 blue is drawn, right? You know, the calculator or whatever, it does the work for us. Okay, it does the work for us. Okay, so I'm gonna draw the other one. And this piece is gonna be on the other side. There we go, right? Do you see these 2 pictures are so similar? They're so similar. So now we just have to draw the hypotenuse, right? So this piece, I'm going to put it here. Wait, no, it's just 1 minus root 5. There's nothing fancy about it. Okay. So that's 1. I'm gonna use a different color. Okay. And the next one. There, the 2 terminals are drawn, right? So how do I make them prettier? The line, oh, we want it thin. Okay, we want it to be thin. Too thick. Whoops. Oh, wait. This piece. There we go. That should do it. No. What did I do? That's one. Oh, make it thin. And let's add another one. Okay. That should do the work. Okay, you can see how similar they are. The only thing that's different is the numbers are different, right? So you treat it the same way. You treat it the same way you would have, right? And there we go. In terms of angles, same idea, the same idea, right? So the angles, we're gonna assume this angle is theta. Okay, we're gonna assume this angle is theta. And this angle is in the range of arc sine. Okay, this angle is in the range of arc sine. Okay, so what we do here is that we're gonna introduce that angle, right? So theta is equals to arc sine of this number. So that's the theta. We have two terminals. We have two terminals, right? So one solution would be x equals to theta plus 2k pi. And of course, we know we have another solution which terminates over here, right? So how do you measure it? How do you measure it? You can measure it any way you want. Okay, from standard position terminates here, right? And that looks like it's going to be pi minus theta. Why minus theta? Because theta itself is negative. You have to minus theta to add this additional piece. Okay, so this piece is going to be pi minus theta plus 2k pi. Okay, let me say it again. The reason we minus theta because theta itself is negative, right? We want to add an extra piece here, okay? So this is pi. This piece is pi. You have to add a theta, but theta itself is negative, so you have to subtract theta to add you add the opposite of theta, so which is plus theta, right? You plus this much. But anyway, so that will be the solution. And these are the solutions. Okay, and you can express it. You can express it in the following way. Okay, that way we're rather used to. Okay, so theta equals to, we already have theta defined, right? So pi minus theta, k is an integer, and theta has to be well defined. Is theta well defined? Yes, theta is well defined. Okay. So this picture is not necessary. I put it here just for comparison. Okay, comparison. And if you want to compare more, you can compare the special angles. It will be the same thing. They're just very similar. The only difference is that the angles are different. Okay. And of course, the second case, there's no solution. So finally it comes to how to show work. Show work. This one certainly is a very interesting question, right? We're solving this equation and we have to do these manipulation, right? We have to do this manipulation. And suppose this is what we do, right? And here we go. Solution, let's see where it can be trimmed. Show work. Show work. Show work. Okay. I will keep most of it for u, right? For u1 equals to that. We solve this. And you can remove this picture, right? That was for comparison. And for the second one, for the red, for this piece, you don't need to show that really. But if you show it, no problem, because this is just to draw a proper picture for me, right? But of course, you need to know how to find it. And the second piece, there's no solution. No solution. Okay, so finally, the only solutions are these two. Do we have another version of it? Yes, there is another version of it. Okay, the other version would be you show the work, right? Another version is that you don't introduce a u explicitly. Okay, you don't introduce a u explicitly. Just remove that, right? And then you just write sine x and sine x. Sine x. Okay, so you just didn't introduce u. Okay, so then you just do one by one. Okay, you remove the u1, right? And you get your solution. And for u2, you can remove that, right? For u2, then you say, hey, there's no solution because it's outside the range. Okay, outside the range, that's it, no solution. Okay, so finally the solution is just this. It's just this. Okay. I am looking at the solution. I'm looking at the homework questions, and I think I would do one more. Okay, I will do one more. This will be example number 10. Solve for x. And this one is sine x, sine 2x minus cosine x equals 0. Oops, sine 2x. Sorry about that. Okay, sine 2x. Most of the rest of them, there are lots of them just a quadratic equation. So you can change them to quadratic equation. So this one is just a little bit different. Okay, but as a matter of fact, this one, what do? Right? We're going to use the substitute for sine 2x. Sine 2x equals to 2 sine x cosine x. That's it. And then you will factor. You factor out the cosine. Okay, so you have 2 times sine x minus 1 times cosine x equals 0. You see, still factoring techniques. So the so-called complex trig equations, in most of the cases, you just have either quadratic form or maybe even degree 3, degree 4, okay? And that's about it academically, you know, you're not talking about very, very difficult questions. Really, you need to have the skills of handling quadratic. You need to have the skill of using quadratic formula. And you need to have the skill to use factoring techniques or, you know, those algebraic skills. And then you'll be able to solve these equations, sorry, you'll be able to solve these equations. And here you don't need to introduce any intermediate variable at all. So you have 2 sine x minus 1 equals to 0, or cosine x equals 0. Cosine x equals 0. And this turned out to be a pretty simple equations, even though at first it might look a little puzzling, but after you get your hands dirty and you realize, oh, actually this question is more simple than a lot of things we dealt with, right? So for sine x equals to half, right? For sine x equals to half, isn't this similar to what? Isn't this similar to what situation we had? The 1/3 situation? I just want to show you guys the similarities of these questions. Okay, there are lots of similar questions there, right? 1/3, right? It's similar to this piece, right? And of course, here we have 1/2. 1/2 is also corresponds to a special angle, so special angle. So I'm going to use this opportunity just to show you the similarity of a special case and non-special case. Okay, so look at the similarity. Right, look at the similarity. Look at the similarity. Right, so this is this is for 1/3. Let me put it on the side. Right, this is for 1/3. And this is for 1/2. Sine x equals 1/2. So what are the terminals we're dealing with? There's one here, right? No, let's not use red. Red is used for something else, right? So there's a terminal here. There's a terminal there. You see how similar they are? You see how similar they are, right? And the red and blue, of course, red and blue, you know the red and blue, right? So the red and the red and the blue. You look at these two pictures, they're almost the same question, isn't it? The only thing is that the numbers are slightly different. Okay, I'm sure you can compose the solution. And the solutions are, and here x would equal to, right? We have two forms. Okay, two forms. These things messed up. Okay, two forms. So one is pi over 6 plus 2k pi, 2k pi. And the other one is 5 pi over 6, right? 5 pi over 6. 5 pi over 6 is pi minus pi over 6, right? Plus 2k pi. 2k pi. So do you still remember what the solution for this piece? What the solution for that piece? Almost the same, right? Except that at pi over 6 is arc sine what? 1/3. And this piece is changed to that pi minus arc sine 1/3. You guys see that? You guys see that? See how similar they are, special or non-special case. If you know how to handle it, really they're very similar, right? They're very similar. Okay, so I'm doing this for comparison. Okay, so this piece, you don't have to show work on these pieces, but for your study, you need to compare examples across the examples, And now look at for cosine x. So what's the solution for cosine x? What's the solution for cosine x? The red number equals 0, right? Where do you get red number equals 0? The red is 0. Oh, we have two of them, right? We have 0 here, pi over 2, 3 pi over 2. That looks like x is going to be equals to what? Odd number multiples of what? Of pi over 2, isn't it? There. So finally, solutions are, okay, we have this form of solution, right? Or, and that form of solution for this particular question. Okay. And you guys get to practice. You guys get to practice. We get a bunch of homework questions out there. Okay, to show work, you don't have to show these, by the way. Okay, I just mentioned earlier. These are just for comparison. These are just for comparison. And for your study, you should do a lot of these comparisons. Okay, so you find a common feature, and then you go from there. And that's how your study becomes more efficient, and you see more and more patterns. Okay. All right, so without further ado, I think we've done enough examples on solving complex trig equations. If you have any question, please don't hesitate to reach out to me. Thank you for watching.